Okay, ladies and gentlemen, welcome for the second talk of today. We are starting now with Schlomo Schapiro. I hope I've pronounced it correctly. Let's start with cloud migration strategy.
Good morning. You might be wondering why I stand here and talk to you about the cloud at a data center conference. The reason is simple. I believe that the cloud is here and it won't go away. So no matter what you do and what kind of business you run, you at least have to face the cloud and think about how to do business in the cloud or why not to do business in the cloud. And you need to have the right answers for your bosses, for your budget owners, as to why you still run an expensive data center while computing costs next to nothing in the cloud. On the other hand, maybe you want to get rid of your data center, and then I can show you a way how you can achieve that as well. Or you realize that all extremist opinions are actually flawed, and you simply want to find the right balance between cloud and data center, and that's actually what this talk is about. If you remember my previous talks at this conference, they were about RPM and packaging and how to run your data center very professionally. We're still doing that, it just works well, and the fact that our data center runs well actually gave us the headroom to build our new cloud platform. At the end, I'll also share with you some tools which you can use, which are on GitHub, and I hope they will be useful to you. But this talk is more about ideas, concepts, and architecture, and also a little bit about the business, and not only about the tools. So, who uses the cloud, any cloud already? Okay. Who would leave his company if somebody would decide that the business goes to the cloud? Very well. So, are you sure that's a good choice?
No, it's just a joke.
Okay. So, that's the goal, right? Have our data center in the cloud. Don't need to get up at night anymore, hopefully. Actually, our goal is a completely different goal. As Immobilien Scout, we make money through technology. But technology is just a means to help our business. So going to the cloud for us means going to a world where innovation happens on its own and we can just benefit from that instead of inventing our own wheels over and over again. And that's the main motivation for going to the cloud. It's not financial, it's not the cloud is cool, it's much more, let's achieve more with less. So, the cloud migration. Your manager stands in front of your desk and says, I read in computer build that there's now this cloud thingy and it's all cool and let's do that. And you look at him and above his head you see this. A plan. How to move to the cloud. Right? Who had this experience already? I'm so sorry, you'll have to spoil that vision. It doesn't work like that. And here's why. Okay, use this picture, don't say anything. But in fact, just ask about stuff like the timeline. How long do you think it will take us to go to the cloud? Or how will we play security and resilience in the cloud? We have a data center now, we know how to do this stuff in the data center. In the cloud, it all works different. How and when will we learn how to engineer our applications and services for the cloud? And last, of course, but not least, the budget. How much can it cost? How much will it cost? If you tell your manager that the cloud is twice as expensive as the data center, he'll ask you why. If you say it costs only half as that what you pay in the data center, he will also ask you why. Because in one case, you maybe blow it out of proportion. The other case, maybe you're too expensive right now. So no way how it goes. You lose, actually, as long as you don't have the right answers. So the interesting part is actually time and money. This is a typical budget plan for data center, heavily simplified for this conference, where you have blocks that typically happen in a range of 3 to 5 years. And each block is like something expensive, like central storage, 1 million euro. Server hardware, another 1 million euro. The core switches, networking and stuff, another 1 million euro, and so on. And all that is bought on a regular base, written off over 3 to 5 years, and then bought again. So in the end, you have some kind of a budget curve over the years that represent the investment into your data center. And one problem is this is capital expense. That's investment. And if you go to the cloud, it looks different. In the cloud, you have operational expenses, and there are some tricks to turn that into capital expenses, but trust me, they're tricks, and it's a lot of work to get them done. So let's say you start moving to the cloud. In the first year, you start obviously with nothing and move on. And then happens something we call the miracle. Cloud is cool, and your costs explode. And then in the next year, you tell your engineers to invent this little device in the hope you hope that this will solve the problem. Or your engineers tell you that it won't work this way. And then you come to this kind of idea. Okay, let's reduce costs in the data center to free up budget for the cloud, and let's make a cloud migration that will somehow balance those two processes. Data center cost going down, cloud cost going up, so that the total cost won't explode. And actually, as a business owner, I want the total cost to go down. So I'm ready now to invest into the cloud migration in order to get future savings and some eventual return of invest on my investment into the cloud migration. And that's what we did at Immobilien Scout. We actually started by writing a business plan that looked approximately like that and foresaw a cloud migration over several years with an eventual return of invest after, I don't remember, something like 7 or 10 years. And that was the first shocker. So, okay, cloud is cool, but actually you don't go to the cloud to really save money. You go to the cloud to do more with less. You go to the cloud to be faster and to stop inventing stuff that exists already. And that was a very big lesson for me when I started to really understand what's going on with cloud and data center. And that's actually the reason why I believe that in 10 years from now, data centers will be something of a specialty. Just because everybody has the problem that they need to do more with less, more services with less people, more features in less time, and so on. So you can't do that while you still dig your own coals and mine your own metals and build your own tools and everything if you want to build a car. You buy all that ready-made and then you build your car. Same about IT and especially web IT where I work now. The question is, and that's something you have to find out for yourself, how many years does that take? How long is this process? And that's really a business decision, not a tech decision. You as technicians, as engineers, can make that happen very quickly. You'd love to make that happen quickly. Nothing is greater than a 3-month rush to the cloud where you work day and night and then you pull it off and everything is cool. But your business won't like that because it's way too expensive. Let's look a little bit at engineering questions that arise, and the stuff I'll show you now is basically stuff that I learned over the last 2 years. And I'm happy to share some experiences with you. So, please keep this in mind. Print it out, hang it over your desk, whatever. Keep it in mind. Cloud means scale out. If you do something in the cloud that does not scale out, it will fail. And it will fail when you don't expect it. We don't need to talk about DevOps anymore, so the essence is automate or die. Those who don't automate will die out. That's just natural evolution. If you automate, please do test-driven development. And actually, you can't do test-driven development without a really good automation. Because if you code everything, if you code your infrastructure, then you can also write tests for that, and then you can make a change and just see how it rolls through your platform without any worries. And in the cloud, even more than in the data center, everything will fail. Amazon actually guarantees you that components will fail. Yeah, it's just a fact. And if you don't build for failing components, then they will fail when it doesn't fit your plan. For example, when you sit in the cinema for your wedding anniversary, then it will fail, because that's just how it is. So let's move to the cloud, right? We have a data center and a migration plan and a cloud, right? Who is doing that? Startups. Okay, well, does it scale? Is there any scale in this picture? Where's the scale? Exactly, there's no scale. Okay, let's move to 2 clouds. Right? Is that scale? No, this is scale. If you move to the cloud, I believe that you will be moving to many clouds, and you'll be moving from one data center to lots of data centers. At Immobilien Scout, we now have something like 50 data centers. I actually didn't count them anymore, because we create AWS accounts for everybody who needs one. And each AWS account is like its complete own data center. It's actually a multitude of data centers, because the closest thing that you can compare with a physical data center is a VPC in Amazon. And if you have multiple VPCs, then you already have multiple data centers. We actually have 2 physical data centers, but in the cloud we'll be having 50 or 100 or maybe 200 or maybe thousands. We don't know. But we built our tooling so that it doesn't matter. And that's the thing about cloud. You always have to scale out, no matter what you do. Think about scale. Scale at every level. If you want to know more about that, look at the stuff that the Zalando people are doing. They really scale at every level. They scale people, teams, technology, everything. And they understood why they need to scale at every level to meet their business demands, which is extreme growth. It actually doesn't matter how you purpose those multiple accounts. It's possible that you say I have a live account, a staging and a play account, or you can say I have business cuts where you have one business unit that does search and the other does user management, or you have team accounts. It doesn't matter. What's important that you have many accounts. And if you need one argument to convince somebody, take the following. If you have everything in one account, you will fail on Amazon resource limits. Meaning, let's say you have everything, live, staging, playground, production, whatever, in the same account. And somebody decides, I want to see what happens if I scale my Hadoop cluster from 100 nodes to 1,000 nodes. Amazon will be happy to oblige, and you pay for that. The problem is that in the next minute, your production web cluster needs another 10 instances, and it won't get them because you hit the Amazon resource limit. It's always there. You can actually check where it is, and you can increase the limit via ticket. But there's no guarantee, unless you manage those things, that your production systems will get the resources they need to automatically scale up if you have other stuff running in that account which you don't control. Argument. For me, this is a very big argument. Just containment of all kinds of risks. A breach in one account, contain it within the account. Resource abuse, contain it within that account. High security requirements, compliance requirements, whatever, contain it in one account. Contain stuff in accounts to make your life easier and to keep things under control. Don't have this big supertanker account. Have a lot of little boats that can go quickly in the direction that you need. There's another thing that really wasn't obvious from the beginning, which is communication. In the data center, you typically have something like that, which is an enclosed space with lots of servers talking to each other, and you have perimeter security. You have some outside wall that protects the data center, and that also actually protects your office, because from the office you talk to the data center through some kind of a tunnel, and that is secure. In the cloud, that changes. Each cloud account is now its own data center. And if you have services communicating between the cloud accounts, they will do that over the public internet. Just keep that in mind. This is a fundamental change. For example, you have a different kind of latency. In your own data center, you have local area network latency. In the cloud, even between accounts running in the same region on Amazon, you have medium latency. You don't yet have high latency, like going to another continent or country, but you have medium latency. And you don't have the low latency guarantee that you used from the data center. Keep that in mind. Also, you need backdoors for admin access, because you don't want everybody to be able to use the admin access. In the data center, you have the backdoor because you come from behind through your whatever VPN into the data center, or you have an office in the data center, and that's easy. In the cloud, you have to do something for that. Keep those things in mind that change the way how you do your IT in a fundamental way, and that's not obvious from the beginning. Paint pictures, visualize where you put the components. And if you haven't thought about microservices so far, now's the time to do that. Because you can take the same picture and write here cloud migration, or you can write here microservices, and the picture is correct. Some while ago, there was the microservices meet conference here in Berlin, and it's very interesting for me to see how all the microservices people talk now about stuff which we talked about for cloud migration. And I realized that basically microservice conferences are for developers, and DevOps cloud conferences are for ops people, but the structure change they talk about is the same, and that's that you go from one monolith to many smaller units. And this same pattern repeats itself over and over at different scales, at the large scale and at the small scale. The pattern is the same. We build smaller units from larger ones. And then we start to pay attention to communication and orchestration, which start to be a major part of the solution. And finally, please automate your stuff. The era of doing things manually is over. And I don't know what you want to give your kids as a legacy, but please don't teach them how to do stuff manually. Teach them how to automate. Why is that important? If you look at the typical data center stack, simplified, starting from hardware, network, and storage on the bottom and going through application configuration to the load balancer, then the typical degree of automation looks like that. In the bottom, you have very little automation. Yeah, nobody has a robot that plugs hardware into the rack. Maybe Google does, but we don't. Most people have solid automation for configuration and for the application. Some have solid automation for the operating system, if you've seen my previous talks. And actually, amazingly few people have little to no automation for stuff like load balancer, DNS, and other front-facing technologies. And for the data center, that works because you can still count the units you have there. It's still kind of manageable. And maybe the effort to automate all that is not worth the benefit. Actually, that was part of our motivation to look at the cloud, that we realized after automating all that stuff will be way too expensive for a company like Immobilien Scout. So if you look at the cloud, the picture looks different. You still have the same things, but you have a uniform way of automating them with something, for example, called CloudFormation in Amazon or Terraform in others or whatever. Everybody has that now. Yesterday there was a nice talk about that. And in addition to the traditional data center services, you have also more services that are part of the same automation. And all that is actually just code. If you use CloudFormation, then you have one large JSON file, which is code in this case, describing the entire environment. So you must actually do infrastructure as code, and you must automate that. Because if you don't, you'll be afraid to change it. And if you're afraid to change it, you'll be stuck, and you won't progress anymore. The next thing we have to think about is resilience. Resilience is, for me, simply this thingy here, which is doesn't matter how you push it, it stands up again. That's resilience for me. I want to be my data center or my services so that No matter who kicks them, who hits them, who abuses them, a little bit later they will stand again and continue to do their job. So, for those of you who already do stuff in the cloud, here is a very typical example of a standard textbook web application in the cloud. You have the user, you have a load balancer, you have an auto-scaling group with a few EC2 instances, you have some database under that, which has kind of its own shadow copy, and the verticals, by the way, are availability zones, just imagined. And all that is surrounded by VPC because it runs in the VPC, and all that runs in a region, and all that is set up with 1 or 2 CloudFormation stacks. Looks familiar? Who of you does stuff this way? Who set up stuff like that? Nobody? You all do something different? Hi, good morning. So, do you think that this is resilient? Is this a resilient setup? No. Why? Because there's a really large amount of single points of failure in this setup. Take the word single. Everything that exists only once in the setup is a single point of failure. You have one ELB, you have one VPC, you have one region. You have one RDS thingy. It's a single point of failure. You have one CloudFormation template. It's a single point of failure. Yes, please.
The load balancer is not a single one. This is a fleet of instances.
It's one thingy. If you misconfigure it, it's broken and you're down. It's a single point of failure. Yes, it in itself has redundancy, but this is only technical redundancy. If you misconfigure an EC2 instance, on the opposite, the autoscaling group, if you did it correctly, will recognize that the EC2 instance is broken, and it will stop the upgrade and roll back to the previous version. That's why in this setup, the only thing that is really redundant and reliably redundant is the EC2 instance. Everything else is a single point of failure. And in the data center, we're better than that. We have 2 data centers, they're completely independent. They're really 2 load balancers that don't share their configuration except by copy. Means if I mess up one load balancer, the other is not messed up, and so on. So we have more resilience than that in our data centers. And to get that same level of resilience in the cloud, you have to go the same way. You need to double everything, even if that's totally stupid. But that's how you get resilience in the cloud. You have multiples of everything, and you manage that with automation. And that's really hard. That's a lot of work. Don't take it easy. It's more work than in the data center because you won't be doing that manually. You'll be automating that. And you'll need to invent frameworks and data models and orchestration and whatever to handle a rolling upgrade that covers both parts. What about security? I hope that everybody now thinks of security as something basic and built into everything we do and not as something we add on later after the first audit. So, security for me is about 60% really related to static credentials. Who's using static credentials? Okay, everybody who didn't show his hand didn't understand the question. What are static credentials? Static credentials are credentials that don't change. Yeah, the key with which you open your door at home is a static credential. It doesn't change. Your car key, actually, may be not a static credential, because the code it sends to the car changes over time. So again, who's using static credentials? Thank you. Everybody, and that's a big problem, because they're just broken by design. They come from they come from the last century. It's old stuff, actually pre-IT stuff even, static credentials. They make things easy to try out, but they're actually not good for production. Because you don't know when they're copied, you don't know when they're used, you don't know anything about them. You can't track them. Let's have some examples. My favorite example, SSH keys. I always say copy and crack at home because that's what you can do with them. Yeah, rainbow tables, whatever. Just copy them and do with them whatever you want. There are alternatives. SSH host-based authentication. Maybe don't use SSH if you don't need it. Or at least use the SSH agent. Don't ever copy your personal SSH key anywhere. And please don't use user SSH keys for service communication. SSH is a human protocol, not a machine protocol. Machines have much better ways to talk to each other. The next example, and a classic for conferences, are AWS credentials. They are static credentials. And if I see somebody flashing here his credentials, I'll make a photo and I'll install my happy, nice Bitcoin mining, porn, whatever distribution in his account for free. And if he's a dummy and flashes me master credentials with IAM permissions, I'll just set up my own users there and hide them in his system. And I'll name them something obvious like AWS system account, which he probably won't even realize. Don't use static credentials. Period. Okay? Amazon has other means of authentication. Use them. We have software for that. Use our software if you don't have your own. And please watch your CloudTrail logs. And of course, username, password. Really, this is yesterday. So don't do that anymore. Don't do back-end admin access with a password that never changes. Like, how do you log into the monitoring web UI? Monitoring. Disable it, please. Or integrate the login with your Active Directory, whatever employee management system. But don't do username, password stuff. It will fail, it will be stolen, you'll never know when, and it will be a big, big annoyance. Let's look again at this data center and try to understand the built-in challenges if we want to move to the cloud. So as I said, we have a lot of blind trust going on. Because we're in the data center, nobody can get in there, we have this perimeter security and so on. And we do a lot of stuff without authentication, because in the data center that just works, and it's okay, it's good enough. Yeah, it doesn't matter if, whatever, the secretary or the boss can also read my server configuration page. They probably won't, but they could, so it's still okay, because they're still part of our company, we trust them. So how to mitigate all those? Well, in the end, an app has to be completely responsible for its security. There's no way around that. Forget about web application firewalls and offloading security concerns to other teams. You write an app that runs on the internet, you are responsible. And you have to make a security audit or ask somebody to do that, and you have to fix everything that they find. The blind trust in the data center is another big problem. Services in the data center usually can communicate to other services just like that. I don't know many data centers that have really firewalls built in, like host-based firewalls. So again, the answer is local firewalls. In the cloud, you have something called security groups, which make that really, really simple because you just say who should talk to each other and everything else is forbidden. But you have to think about local firewalls, not global firewalls. Because the enemy will be within. A hacked server is your enemy, not the evil internet. And please remember, firewalls have open ports for your work. Yeah, the main business ports are always open in the firewall. The firewalls only protect against the negligent admin who forgot to close MySQL to the outside or something like that. That's the only use of firewalls. No authentication is a big no-no. So please do federated employee logins. Everybody of you has a work email with a work account and a work login. Use that for what it's there, to identify people versus machines. Use that everywhere. Build frameworks to make it simple for your developers to integrate employee login everywhere. Once you do that, once you provide those frameworks, you won't have any more discussions about static credentials because nobody needs them anymore. Look at Google. You can log in with your Google account everywhere at Google, right? It's so easy, so normal. Why not have that internally as well? And we don't use VPNs. So instead of having some special backdoors, we build jump hosts. We trust our jump host, and we say the jump host checks the identity of the person who comes, and then the jump host is a trusted source of communication within each data center or network. And the biggest thing is service-to-service communication. It goes over the public internet. And this is a real biggie, because over the public internet you can't trust anything. You can't trust anybody. So here, you have to do something. My advice is HTTPS only, secure communication, and use identity management together with federated authentication, for example, OAuth 2. We wrote something for that, which is not open source because it's heavily integrated with our other API systems. But CoreOS published something called DEX, D-E-X, which might solve this problem because it's an OAuth 2 or an OpenID Connect provider, with a lot of flexible backends. So probably you can solve this problem with DEX. And this is a very big problem. And if you go to the cloud without thinking about service-to-service communication, you will have a big problem down the road. So, what about hybrid cloud? This is a hybrid cloud, right? It has a little bit of everything, but nothing real. So, one way of defining hybrid cloud is this. My virtual machine or Docker container can run on-premise or on the cloud. Who came to this talk with this opinion? Thank you. It's called IaaS, like infrastructure as a service. I have a virtual machine, and VMware and others offer you cloud services where they allow you to bridge between your on-premise VMware stuff and some cloud VMware stuff. And AWS has some migration wizard, and Microsoft has that, and so on. There's another definition, which is like this. Use the best tool for the job. Some apps ran better on-premise, and some apps run better or benefit more from the cloud. Embrace cloud services as part of our applications and integrate with them. Who came with this opinion to this talk? Okay, nice. Because that's actually my opinion, and I strongly believe that going to the cloud without embracing that what the cloud offers doesn't make much sense. It doesn't give you much benefit. You could also go to Hetzner or another bare metal hosting provider. Probably cheaper even. So how do those compare? Running your stuff anywhere, of course, has the advantage that you don't have a heavy vendor lock-in. Yes, that's a big advantage. Write once, run everywhere, runs from my desktop through the data center in the cloud. I have unified tooling, and I can even say I have one standardized abstraction layer that knows how to orchestrate my on-premise on-premise virtualization farm, and my cloud provider 1 and cloud provider 2, and so on. Yes, there is a benefit to that. The downside is you have to still invent all your own stuff. You have to roll your own database system. You need your own people who will create databases that run in an automated fashion. So the other thing is use the best tool for the job. Biggest advantage is you can actually do stuff without servers. Look up serverless or serverless Python. There are frameworks that allow you to host web applications without a server. Where everything is in the cloud, you just take some cloud components, wire them together intelligently, and you're done. It's amazing. And the amazing thing is that if you do that, and it's a low volume application, you can run it for €1 per month. And there's no way how you can run a website for €1 a month with backend and storage and persistence and interaction and security and so on with other technologies. It's just technically impossible. Even the lowest, smallest, tiniest instance costs you already 10 euro per month. And it doesn't even have persistent storage. And in your data center, I don't believe that you get down to 1 euro per month per virtual machine. Okay, so think about the benefit you can actually get out of taking the cloud at its full potential. And that's why I believe that you should always use the best tool for the job. Right? Even if the tool is the hammer, then not every problem is a nail. So let's use the best tool. Another thing to keep in mind, you probably all know this 80-20 thingy, which you can apply to all kinds of arguments. So I applied to this argument. With managed services, you have 80% benefit for 20% work. And with virtual machine hosting of any kind, you have the opposite. You have 80% work for 20% benefit. Because the moment you start virtual machine hosting, you have this big bag full of complexity and problems and things you need to automate. Using managed services is just a little bit JSON to create it and then just API calls to talk with it, and that's it. Nothing else you can do with that. And that's just so easy and so cheap to use. Feel free to use this argument any way you like. So, I'm a strong believer in cloud enablement, meaning I don't want to force people anywhere, neither to the cloud nor to the data center. I want to enable people to do their own choices based on what's best for them. And that's my advice for the cloud migration strategy. And at Immobilien Scout, we kind of follow this plan. We had a more aggressive plan some time ago, but we changed that towards a more measured plan that really takes the time that everybody needs to go into the cloud and also allows people to use the data center if the data center is better. So what's the cloud migration strategy? Establish a cloud platform. That's the first step. You can't ask people to decide about something which they can't try out. The next step is integrate the cloud with your data center. Embrace the fact that you will have 2 or more platforms for the foreseeable future. Don't play this like, okay, we build now everything in the cloud and we neglect the data center, we'll just switch it off anyway. That's bullshit. Expect and embrace a long migration period. If you then can make it shorter, that's okay, that's great. But first plan for a hybrid world and optimize for that. Build technology for the hybrid world that really makes everybody see the benefit of being able to use both, to have the free choice between cloud and data center, or multiple clouds, because different cloud providers actually have different advantages. Whatever, Microsoft is better with machine learning. Amazon is better with everything else. I don't know. These things change. Google suddenly develops a new service and you want to use it. So integrate those clouds into your data center and then look where that takes you. Build new applications in the cloud. I think that's an obvious step. If you invest engineering into a new application, the overhead to build that on a new platform is usually pretty small compared to the overall effort of that new product. And then it's okay to say, okay, we have a 10% engineering overhead to go to the new platform, but that is future-proof, avoids technical debt and so on, and then everybody will be happy with that. Especially since product owners know that any estimation you give in the beginning is actually wrong. So they don't care about 10% more or less. Then start to migrate existing services. And then repeat until done. Because obviously, that's not the end of the story. In detail, the cloud platform as a platform is as important as your data center platform. And please take your cloud platform as professionally, as stable, as well engineered as your data center. Don't play this, okay, we are in the data center, everybody can go to the cloud, we don't care how they do stuff. Because in the end, you'll be still responsible. You, the ops people, will still be responsible for the mistakes that others do in the cloud where you actually don't deal with. So better you embrace it, you deal with it, you make it your own, and you provide a platform both in the data center and in the cloud. That means provide basic solutions for logging, monitoring, deployment. Provide good solutions for security, compliance, and cost control. I actually forgot that on this slide. That's very important because security, compliance, and cost control are topics which nobody cares about. Nobody who writes applications cares about those things. But your company cares about those things. So somebody has to be responsible to implement software and technology to care about those things. And if you are now an ops department looking for new purpose, then take this as your purpose. Taking care of things that nobody wants to care about, like the overall responsibility. Make that your business and be excellent at that. And you won't be out of a job. Very important also, give your users easy and secure access to the cloud. Don't let them create IAM users. Don't let them create static credentials. Use, if you need, our open source products to provide access to the cloud. But don't let them create users. This is evil. And please decide upon the macro architecture, the big questions. Like, do we have multiple AWS accounts? How are they cut? How do we do communication? How do we do whatever, services? Try to decide upon some standards, like we use CloudFormation to automate everything, or we use Terraform to automate everything. Set policies. You should use all services at AWS. Please don't use anything except EC2 and S3, or whatever. Set policies, give the people some boundaries within which they can freely go to the cloud, freely explore their abilities in the cloud. The next step is bring the cloud to your data center. Don't see the cloud and the data center as two separate entities. See them as one, because it's one platform, one Immobilien Scout platform. And the one Immobilien Scout platform has drivers for the data center and drivers for the cloud drivers. We actually don't have any abstraction layers that are overarching because we want people to understand the tools they use. So in our world, people use VMware native or through our very slim automation, and they use AWS native through CloudFormation. And we have a very, very slim wrapper that allows you to write CloudFormation in YAML because YAML is shorter than JSON. But that's it. Everybody actually writes CloudFormation, and people hate it, but I still think that in the long run, the company is better off with everybody knowing CloudFormation than if people would learn some other abstraction tool that, again, will limit them in the way how they can express themselves in the cloud. Go native. Always go native. Provide a secure communication framework. If you don't solve these challenges, how to communicate between the data center and the cloud in a central level, your developers will solve the problem for themselves in a way that doesn't scale and that maybe isn't even compliant with your own requirements. So go ahead, take the step forward, invest into solid framework solutions that allow your developers to be quick and efficient with what they do. And that's, in my opinion, the job of every infrastructure department. And then start using cloud services from the data center. For example, prime example, SNS and SQS is a queuing solution. And if you run a queuing solution in the data center, check how much it costs. Check how much you paid for building it. And then compare that with the prices of SNS, SQS. In our example, that actually was a big, big win. We, a couple of years ago, had to take the decision, do we build the next mega large queuing system for all the events happening in the data center, or do we just use Amazon? The decision was just use Amazon. The price tag was something like 1,000 euros per month. And actually, the amount of meetings we saved by taking that decisions already brought us a return of invest. Not to talk about engineering time that would have that it would have cost to build a solution on-premise. And think about migrating storage to the cloud. Because if you look at a migration, you always have storage and code that you need to migrate. And if you migrate the storage first and the code second, the migration will be much easier. Especially since cloud storage is a web service like S3 or DynamoDB. So if you use the cloud storage from the data center, then you can actually shift the web servers or the workloads to the cloud without moving the data anymore. And that means you can do a seamless migration, a transparent migration from the data center to the cloud. Build the data migration into your application because your application knows best how to store data. So if your application now writes into a database, let it write also into a cloud storage in parallel, and then eventually you can switch off the database. And very important, improve automation and gather operational experience. Because you will have failures, you will have errors, you will have fuck-ups. You will have human error most of all, and you need time to learn how to deal with that. There's no money in the world that buys your experience, only time buys your experience in doing it. So use the time to build up experience within your company, within your developers, within your admins, that they know how to run resilient platforms in the cloud, how they can run available services in the cloud with different means how to achieve that availability. Then you're ready to build new applications into the cloud. Start small, go big, whatever, it doesn't matter. This is a business decision. Because here you need to talk to your business, you need to involve them, and you sell to them this idea of let's go to the cloud, and this project will take longer, but all the next projects, they will take only half the time because we'll be faster. And that's the main argument here. And this is the step where you really learn how to architect for the cloud, how to actually design your application to work well in the cloud with the tools that are available there. And you will learn how to control your costs. Because you learn that setting up a Cassandra cluster with several availability zones is just very expensive because you pay for inter-zone traffic on Amazon. And you will make expensive mistakes that will cost your company $5,000 over one weekend. And you'll have to be ready for that. Your management has to be ready to forgive those mistakes. Otherwise, you'll never learn. So, develop an architect for the cloud and for the costs is something completely new, which we didn't do in the data center. In the data center, the smallest box was very powerful. There are no tiny boxes in the data center. There are no fractional boxes in the data center. In the data center, everything is powerful. Network performance, no big deal. Storage performance, no big deal. Memory, how many gigabytes do you want? It's cheap in the data center. In the cloud, you have to engineer for that and for really keeping your costs under control. And again, improve automation and gather operational experience because you will fail again. And you will learn that you make a CloudFormation update and that gets stuck and you are down. And you will learn how to deal with that. And if you skip this step, then you will fail big in the next step, which is to migrate existing services. And here we go back to the business plan, which I showed in the beginning. Because most likely, the business plan or the investment plan for your data center will dictate your cloud migration. You will ask yourself, which services do I have to migrate now so that I can avoid the next $1 million storage investment in autumn? And then you realize that you have a really big project in front of you because everybody is using storage. Obviously, right? That's why we have central storage, so that everybody uses it. So then you ask yourself, okay, what do I have to migrate now into the cloud so that the next storage investment will be only half as expensive as the current one? And then you find some things you can migrate to pull that off, but the downside is you actually bought another storage, which you have to write off another 5 years. So there you go, another 5 years in the data center, for sure. And that's the things you need to discuss at this step. And you need to prioritize cloud migrations against feature development, because migrating existing services doesn't create new features, and it maybe doesn't even make anything better. So maybe you try to integrate your cloud migration into some refactoring or some new feature that is much easier to implement with the cloud than in the data center. And again, please improve automation and gather operational experience. Repeat until done. Obviously, after we migrated everything, you'll start to think, where do we go next? Right? After we migrated everything from our old legacy platform to the new shiny RPM-based, fully automated, virtualized data center, we go to the cloud. And we go to the cloud earlier than later because we actually know that one migration is just the preparation for the next migration. And I know that once we migrate most of our stuff to Amazon, we'll be in a much better position to discuss how to migrate the stuff that would benefit from it to Google or to Microsoft. But it will be much easier because we're already in Amazon. And if you work in one cloud, going to the next cloud is much easier than if you don't work in the cloud at all. And very interesting, the less stuff you have in the data center, the more expensive the data center gets per service or per application. So in the end, you can play a very simple game. You say, I give you a data center, I give you the cloud. You, my dear internal customer, can use whatever you want. I'll just tell you how much it costs. And suddenly, the remaining data center users will discover how expensive it is to run in the data center, because they get all this overhead that the data center incurs assigned to them. 10 admins, housing, energy, whatever, all that it takes for data center, uplinks, suddenly goes on 5 applications. And then those 5 applications have a new way how to decide if they better want to be in the cloud or if it's worth for them to pay the data center for what they do. Please improve automation and gather operational experience also at this step, because otherwise you will fail. And please always change the running system, because if you stop innovating, you'll just get stuck. So, all that comes with a toolbox, which we publish on GitHub, which you can use freely, and we'll be happy to get your feedback and pull requests. There's much more than what I list here, but these are the major things that are worth looking at. So, compliance is a big thing in Germany, and we wrote a tool that deletes resources that do not run in Germany. Because we say, just delete them instead of tolerating them for some time. And we just have a policy that says, thou shalt not run stuff outside the EU, and then we are fine with all this data privacy laws. Very important is security. So we wrote a solution that gives AWS credentials to our employees and to our data center servers. It's called Amazon Federation Proxy. Go to this link, there are slides, screenshots, talks, and you can just install it and use it. And this software really takes away all excuses for using static credentials. It's in Python, feel free to modify it. And it integrates with your employee login by using the Linux authentication. So if you have a Linux server where you can log in with your employee user account, then you can use our software. And of course, it supports multiple AWS accounts, and you can assign IAM roles in the AWS accounts based on group membership. Very important, we have a jump host that uses OpenID Connect to authenticate users. Problem here is that if you run in the cloud, you don't usually have your employee user database available as a backend service. And I wouldn't recommend extending your LDAP or whatever through a VPN into the cloud. So what we decided is to build a web solution, which is a jump host where you can log in with OAuth 2, which is OpenID Connect, and upload your SSH key. And then you can open an SSH session and do whatever you want. And we said, okay, we want to be sure that only humans use that and no machine communication. So every night we just kill this instance so that every morning you have to re-authenticate so that people who were who left the company actually can't continue to use that jump host. And this jump host is actually not tied to Amazon, so you can also use it in the data center or in any other place where you want to have a secure and reliable jump host. We have a tool that simplifies working with CloudFormation because CloudFormation does not handle the orchestration between multiple stacks. So CFN Sphere will allow you to set up an application that consists of many stacks, and it will make it easy for you to connect the outputs from one stack to the parameters of the other stack. And using that, for example, allows us to have a stack that contains the VPC and then to use this VPC ID in all the other stacks where we have to use a VPC ID. But we do that via variable referencing, similar to what Terraform showed yesterday. And last, if you use Lambda functions and write them in Python, then take a look at this little tool, PyBuilder AWS plugin. It will greatly simplify writing Lambda functions in Python, uploading them to, packaging them as a zip file, uploading that to S3 and registering it with Lambda, which is a typical process for Lambda deployment. There are much more tools on our GitHub. Please also look at the GitHub of AutoScout24, who also work in the cloud and who also have a whole bunch of interesting tools. It's github.com/AutoScout24. And you'll find my talk at this address. The other address, you'll find my previous presentations, and please contact me, for example, via Twitter if you have any questions. Thank you very much.
Thanks. Any questions?
Hi. My first question is, what is your internal policy regarding vendor lock? Can developers use all the services from Amazon, or?
Yes, yes. We decided that Amazon is not a bad vendor to be logged in with, and definitively preferable over Oracle, for example, with whom we have a vendor login in the data center.
I think that Amazon could be the new Oracle, but this is a topic of another discussion. My second question is, how did you solve the connectivity latency during this migration period? If you have some services running in your data center and some of them on IVS, do you have a dedicated connection between your data center and Amazon, or?
No, we don't yet have a direct connect, but you should know that if you exceed a certain amount of volume in your traffic with Amazon, it actually pays to have direct connect because that will reduce your traffic costs. What the other question was about having a single domain like www.immobilienscout24.de, and behind that you have /search in the cloud and /offer in the data center. So for that, the easiest way is to use CDN as a URL routing solution. You can use CloudFront, you can use any other CDN that can simply route different /paths to different backend services.
Thank you.
Any further questions?
Do you expect that everything from a data center is moved to the cloud in the next years, or do you think you will keep something in the data center?
I think that we'll be having the data centers for, I don't know, 5 years more or so. My personal opinion, this is not official. But I also think that in 10 or 15 years, nobody will be running data centers unless they have very, very special needs. In my opinion, physical data centers will become a thing of special needs. Like you need to run your super large Hadoop cluster that runs 24/7 heavy jobs. Then probably it's cheaper to have that in your own data center. But for commodity and standards software, web services, I don't believe that it pays to have a data center. The question is only when. Same like about electrical cars. The question is not if, but when. So the question is, do you want to jump on the wagon in the beginning or in the end of the journey? How long do you want to run next to the train before you jump on, kind of, if you know those Western movies?
So anyone else? Okay, then thanks.
May I just share something regarding cost? We are currently in discussions with Amazon regarding the cost if we migrate our infrastructure there, and we calculated our internal cost for the internal data center combined with the operational cost, and we're still at like 30% of the cost at Amazon.
Yes.
It's
Yes.
still way more expensive, more expensive to have it costed in Amazon than our own data center
Yeah.
with operation cost.
I'm not surprised. Same about us. The lift and shift migration is never a good idea. What you describe is a lift and shift model. Just take what we have, match some instances to our existing services, and take the storage costs, and that's it. It won't work. That's not how the cloud works.
Yeah, of course, we plan also at least 1 year migration process.
No, you need to re-engineer your existing software to work for the cloud, to be optimized for the cloud. You have completely different architectures and design patterns in the cloud, and as long as you don't embrace them, you'll be always way too expensive there. What you can do is you can do a quick lift and shift and then start to optimize in the cloud if you want to be done with the migration very quickly. Or you can draw out the migration and re-engineer your software while you migrate it. Depends a little bit on your business and your requirements, and I don't know. Maybe now you have the money to invest, and in 2 years you won't have, so better do it now. It's a difficult topic, I know.
We don't want to start a discussion regarding this, adjusting the software with the vendor wall, and exactly this problem in 2 years, that if we cannot afford to pay the bills at Amazon, we also cannot afford the data center because we are vendor wall.
Look, the question is, do you run third-party software, or do you run your own software?
That's kind of both. I mean, we run our own software, yes.
Okay, if you run your own software, then you can change it, and then you can optimize it for the cloud. That's what we do. Immobilien Scout, of course, runs 90% own software, our web platform or web services, so we can change it and adjust it to be always optimized for the platform it runs on. If you run third-party software, like some open the box, insert the CD style of software, then you're lost. You can't change how it's built, so then you're more in the lift and shift world.
In other words, you're trying to play on the vendor lock-in with the reduced price, which is kind of a tough trade-off. If you do vendor lock-in, then it's cheaper in Amazon. If you don't, then it's more expensive.
Yeah, but we believe that Amazon is not a bad partner for lock-in. We have enterprise support, and that works really, really well. And so far, their pace of innovation is much higher than our pace of needing stuff. And we constantly discover new services that simplify things for us. And we believe that Amazon will hold true to their promise not to raise prices, but to only maybe expand services, whatever. And we believe that we will always be able to go to the next cloud vendor if there will be a business need for that. Yes, it's a decision you have to take, and in the end, you and your management have to sit down and agree upon something.
How heavily are you using reserved instances? Because this is a good thing to put your costs down, but then you're bound 3 years as other servers in your data center as well.
I would say cost optimization and Amazon is a topic for its own talk. Look at SpotInst, for example. It's a third-party solution that automates a lot of that. It will use both reserved instances and Spot instances for your auto-scaling clusters and EMR clusters. But it's a big challenge. I know other companies who just have 2 or 3 guys doing only cost optimization.
Okay, I would close now. So we have at least 5 minutes of coffee break before we go to the next talk. So thanks again.